First, we need to talk about what an enantiomer is. So enantiomers are compounds that are non-superimposable mirror images. Let's take your feet, for example. Looking down at your feet, you see that they are indeed mirror images of each other. However, if you try to stack one foot on top of the other, they do not superimpose, meaning they do not stack perfectly on top of each other. If you were to do this, you would have a big toe on one side, then on the other side, your other big toe would be there. In contrast, these two forks are superimposable. If you were to stack one mirror image over the other, they would lay perfectly on top of each other. In chemistry, enantiomers have the exact same molecular formula and sequence of bonded atoms. However, the three-dimensional space in which those atoms are in are different. This is what makes them enantiomers. How we notate the atoms' different 3D arrangements is by calling them R or S. You can see that we have two mirror images, or enantiomers. The R enantiomer will fit perfectly into the yellow receptor. However, the S enantiomer will not fit. We can clearly see that the green sphere will not fit inside the square hole. Here's the first example of enantiomers in everyday life. Limonene. It occurs naturally and is found in oranges and lemons. In the picture, we can see the two enantiomers, R and S. They are mirror images. The S enantiomer gives off a lemon smell, while the R enantiomer gives off an orange smell. We just talked about how receptors bind to only the R or S enantiomer. This is a great example. Our nose is filled with receptors called olfactory receptors. These receptors can tell the difference between the R and S enantiomers. That is why we are able to distinguish the smell of a lemon or an orange. Here's another example of an enantiomer. Thalidomide. It was a drug pregnant women could take to treat their morning sickness. The drug was first introduced in Germany in 1957 by a pharmaceutical company named Grünenthal. Pregnant women could purchase the drug over the counter. To give you a quick time of reference, also in 1957, the Soviet Union launched Sputnik 1, the world's first artificial Earth satellite. In that same year, the famous chess player Bobby Fischer won his first U.S. chess championship at the age of 14. Getting back to thalidomide, I'm going to draw the two R and S enantiomers. We see that they are mirror images of each other. The R enantiomer was great. It treated morning sickness. The S enantiomer was a problem. Pregnant women who took the drug gave birth to infants with severe birth defects. These defects included malformation of the limbs, deformed eyes and hearts, blindness, deafness, and other internal serious side effects. It's estimated that worldwide there were about 20,000 babies born with defects due to thalidomide. About half of them died. It was very tragic. Due to these side effects, the S enantiomer is referred to as teratogenic, which is a Greek word meaning monster forming. Now, it's only logical to think, well, let's just separate the R and S enantiomers and give the good kind to pregnant women. Scientists tried this, and they found that even when only the R enantiomer was given, under biological conditions, like in our bodies, the R enantiomer would actually interconvert to the S enantiomer, so separating them was completely ineffective. During the time the drug was released in 1957, a woman by the name of Frances Oldham Kelsey was in charge of FDA review in the U.S. She refused to accept thalidomide in the U.S. until it was proved that it had no severe side effects. So, in 1962, Frances Kelsey was given the President's Award for the Distinguished Federal Civilian in Service by JFK. Because of her decision not to accept the drug, it saved thousands of women and infants the pain thalidomide caused so many others. Now, in big pharma fashion, Grünenthal the company which made thalidomide, did not issue a public apology for the defects it caused until 2012, almost 55 years after the drug was initially released. One last example of an enantiomer, methamphetamine. Methamphetamine has two R and S enantiomers. In this particular image, we see that one methyl group is coming out and the other one is going back. If we were to flip one image like a pancake, we would see that they are mirror images. The R enantiomer of methamphetamine is commonly known as pseudoephedrine. It is found in many medicines such as Sudafed. The S enantiomer is the street drug known as crystal meth. In methamphetamine, the R enantiomer, or pseudoephedrine, can be permanently converted to the S enantiomer, or crystal meth, in a series of organic reduction, substitution, and elimination reactions. People would buy Sudafed and convert it to crystal meth. This was very dangerous because they lacked the proper knowledge, equipment, and environment for synthesizing reactions. Many makeshift labs exploded. This chemical conversion is why the National Precursor Log Exchange was created in 2006 with compliance to the Federal Combat Methamphetamine Epidemic Act. In order to buy Sudafed, you need to go to the pharmacy counter and give the pharmacist your driver's license. This database only allows a person over the age of 18 to purchase limited quantities of the drug. It tracks and monitors the sales of pseudoephedrine. Now, there is another type of Sudafed with no purchase restrictions. It's called Sudafed PE. The active ingredient is phenylephrine. Phenylephrine cannot be converted into methamphetamine because of the hydroxyl group circled in blue. Studies have shown that Sudafed works better as a decongestant than the alternative Sudafed PE.